Good afternoon. Welcome to APA's monthly webinar series. My name is Billy Zydik, Standards and Codes Administrator for APA. Just a couple of housekeeping items before we get started. This webinar is being co-presented by APA and the Center for Campus Fire Safety and is being recorded. The recording will be posted on our webinar page later this afternoon. You will receive a follow-up email tomorrow with a link to the webpage where all webinar recordings are housed, as well as a link to our upcoming webinars. We have webinars planned out through December, and many are open for registration and have been approved by AIA for continuing credit. All attendees are in listen-only mode. Please type your questions in the chat box, and they will be answered in the order they are received during our Q&A session. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by the presenter. AIA and professional continuing education credits are being offered. Please send me an email at billie, B-I-L-L-I-E, @apa.org to request a certificate if you did not indicate you wanted one when you registered. Also, if you have more than one person attending this session from a central location, please contact me so everyone gets credit for attending. Certificates will be sent within a few days as I am currently at APA-U in Nashville. At this time, it is my pleasure to turn this over to Kathy Tabor from the Center for Campus Fire Safety, who will introduce our speaker. Kathy, it's all yours.
Thank you, Billy, and good afternoon, everyone, and thank you for attending. I just want to introduce Richard Roberts from Honeywell. He's our Industry Affairs Manager. He's also on the Board of Directors for the Center for Campus Fire Safety, and he's the chair of the Center's Codes and Standards and Technical Research Committee. I'm sure you know the Center is we call it CCFS with our new logo. We're a nonprofit, member-based, nationwide organization, and we're the voice of campus fire and life safety officials nationwide. And we're pleased to have Richard on our board, pleased to have him at this presentation today as well. He is also on 13 NFPA committees. He's active with, excuse me, 2 very important UL standards on the technical panels for carbon monoxide. He participates in numerous ICC code hearings and actions and working groups, and he's been active in a lot of this for many years, also active on the AFAA, Automatic Fire Alarm Association, Board of Directors for many, many years. He's now the chair of NEMA, the National Electrical Manufacturers Association. He's chair of the Building Codes Committee. And he has over 30 years of experience in the fire alarm and security markets. So it's my pleasure to introduce Richard Roberts from Honeywell. Go ahead, Richard. Richard?
Sorry about that. Might help if I take off mute. Okay, so thank you, Kathy. Thank you, Kathy. Thank you, Billy. Good afternoon, everyone. Both associations thought it'd be beneficial to have a presentation about carbon monoxide detection for several reasons. First, in recent years, we've seen significant code-driven growth for this technology. Unfortunately, considerable confusion and misinformation about carbon monoxide gas and CO detection equipment remain. And also, typically I answer about 200 code-related questions every year. That would be for, yes, Honeywell employees, our customers, end users, AHJs, and fire protection engineers. And approximately 30% of all these questions relate to carbon monoxide detection. Now, there are new requirements in the 2018 model codes that will impact your facilities, and most importantly, it's going to reduce injuries and save lives. Now, the learning objective for today's presentation is pretty straightforward. I'll start by covering several frequently asked questions about carbon monoxide detection. And as I said, there's still considerable confusion and misinformation about this technology, and knowing the facts will help to ensure a code-compliant installation, which will help to provide effective protection for building occupants. Now, next, I'll provide an overview of some of the key changes to the 2018 ICC and NFPA model codes, as well as providing information as to why these new requirements were needed, how they will enhance public life safety, and most importantly, how they're going to impact your future designs and installations. Then we'll switch gears and look at why the NFPA Standards Council decided to merge, or essentially disband, NFPA 720, which is the installation standard for carbon monoxide detection and warning equipment, and merge those requirements into the 2019 edition of NFPA 72. Now, this topic is generating a lot of discussion here in the last 6 to 12 months, and it's important to understand why they did this and the impact of this decision. Lastly, we'll look at where some of these key requirements that were previously in NFPA 720 are placed in the 2019 edition of NFPA 72. Now, as Billy said, we will have some time at the end of the presentation for a short Q&A session. Also, there'll be several breaks during this presentation to answer some questions. So as you can see, we got a lot to cover in a short period of time. So let's begin looking at the main questions that I get every year relating to carbon monoxide detection. And this first question, it's really popping up a lot in the last 1.5 to 2 years. And it has to do with, is a duct-mounted CO detector permitted to be installed in lieu of where the code requires spot type detection? In other words, can it be used as a primary form of protection? And the simple answer is duct-mounted CO detectors cannot be used in lieu of where the code requires a spot type CO detector, or where a local law requires a spot type detector to be installed. Now, later in the presentation, we're going to go over where the various codes require spot type detection. Now, of course, the next question I get is why? Well, the reason is duct-mounted CO detectors. Why it cannot be used as a primary form of protection is there is no product performance listing for a duct-mounted CO detector. And that's because the alarm thresholds that are used for spot-type CO detectors have not been tested for duct-mounted application. And stop and think about it. The environment in HVAC ducts are typically a very harsh environment, often dirty, a lot of air velocity in there, and this could have a significant impact on the performance of the CO sensing element. So I should point out that even though a duct detector cannot be used as a primary form of protection, it can be used to initiate HVAC shutdown. In other words, a secondary form of protection. All right, another frequently asked question has to do with the coverage area of CO detectors. And often an installer or system designer will have a large room that requires both smoke and CO detection. And because of the size of the room, it requires several smoke detectors, and the designer wants to know how many CO detectors are required. And the simple fact is there are no spacing requirements for CO detectors in NFPA 720, and that's because it's a scientific fact. The molecular weight of carbon monoxide is very close to being identical to air, and an HVAC system, when it's operating, will dominate the flow of the CO within a building. And when this HVAC system is running, it really results in a well-stirred environment within the ventilation zone, room, or the entire building. Therefore, a CO detector can cover an area much larger than a smoke detector. Now, this topic is best covered by a 2007 Fire Protection Research Foundation study. And this study was used by the NFPA 720 Technical Committee back in 2007, excuse me, to determine the placement and the mounting requirements for CO detectors. Another question, it's kind of similar to the one that we just covered, but it has to do with where should a CO detector be mounted? Now, some people, even to this day, say CO detection devices should be installed near the floor, and that's because carbon monoxide gas is heavier than air, while others still think that carbon monoxide is lighter than air, which means the CO detection device needs to be installed on or near the ceiling. Well, as I just said, the scientific fact is the molecular weight of carbon monoxide is almost identical to air, and an HVAC system will quickly mix the carbon monoxide gas within a room, ventilation zone, or an entire building. Therefore, the placement is not dependent on the mounting height. Matter of fact, NFPA 720 is pretty specific, and it permits each alarm or detector to be located on the wall, ceiling, or other locations specified in the manufacturer's published instructions. And again, this topic is very well covered in that 2007 NFPA Fire Protection Research Foundation study. Okay, when a building is required to have CO detection, and CO detection or CO detectors are provided, a question I often get are carbon monoxide horns and strobes required throughout the building for occupant notification, just like a fire alarm system? Well, the answer may be no, and that's because NFPA 720 allows the system designer or a building owner or AHJ to decide if CO notification appliances should be installed throughout the building or limit notification to a specific room or area. Now, specifically, NFPA 720 permits occupant notification to be limited to the area where the carbon monoxide alarm signal was initiated, if and only if the alarm signal from that carbon monoxide detector is automatically transmitted to a constantly attended on-site or off-premise location. And more often than not, the integral sounder in the CO detector is sufficient for occupant notification if that alarm signal is automatically transmitted to a constantly attended on-site or off-site location. So let's talk about parking garages right now. And when a parking garage is provided with CO detection, the question I often get is the installation and maintenance covered by NFPA 720? And the answer is no, and that's because the scope of NFPA 720 covers products and systems intended for the protection of life. 720 does not cover CO detection for public health or worker safety for applications or occupancies like underground or enclosed garages, warehouse loading docks, or automotive repair garages. The alarm thresholds for these applications are typically lower than NFPA 720, and they are specified in the Occupational Safety and Health Administration, that being OSHA, or the National Institute for Occupational Safety and Health Administration, or NIOSH. Now, the gas detection requirements, CO detection requirements for enclosed parking garages is addressed in the mechanical code. Okay, let's now look at not only some of the key changes to the 2018 I codes, but also the NFPA codes. And a couple housekeeping slides before we actually start looking at some of these changes is I want to point out that the comments and opinions expressed during the presentation are mine only. Yes, you know, Kathy said I'm on a lot of NFPA committees, very involved in the ICC process, but you know, My opinions do not reflect the official position of the ICC, NFPA, its employees, or any of the technical committee members. Also, I want to point out that we don't have enough time to really do a real deep dive into these changes and the requirements. You know, we're going to provide a very good overview, but it's essentially like a 35,000-foot overview. Therefore, I highly recommend that you go out and purchase a copy of either the ICC or NFPA codes that are used in your jurisdiction. And I'll go one step further and say spend the extra money and purchase the NFPA handbook or the ICC commentary book. There's a wealth of additional explanatory information in there about many of the requirements that we're going to talk about today, but other requirements as well. Also, all the changes throughout the presentation will be referenced using legislative text. Okay, red strike through means text is being removed, blue underline means text is being added, and simple black text means no change has been made to the code. And there will be a lot of text on each screen. I know that most presenters try to avoid that, but I do this intentionally because I want to provide you with a valuable resource document that you can use during your daily activities. Okay, the first change that we're going to look at is, as you can see up here on the top of the screen, is the 2018 edition of the IFC and the IBC. And it adds new definitions for carbon monoxide alarms and carbon monoxide detectors. Now you're probably thinking, okay, wow, this is not a really exciting change, so why is Richard covering it? Well, this change was needed because there are new requirements that will be covered in the next several slides that essentially prohibit carbon monoxide alarms from being installed in locations that are A, beyond their product listing, and B, in locations that could create a serious life safety hazard. And having these definitions in the code will help ensure a code-compliant installation for those who are not familiar with the differences between alarms and detectors. And if you look at the definition for carbon monoxide alarm, this is the type of CO detection device that is not designed or listed to be connected to a control unit. This is the type of detection device that consumers can go to Lowe's and Home Depot, purchase and install themselves. Whereas a detector, that is the type of device that is designed and listed to be connected to a control unit or a system. And these are professionally installed. So the next series of changes is intended to enhance occupant safety by providing notification to a responsible party of a malfunctioning fuel burning appliance that is installed in a building, but it's located in areas that are remote from dwelling units and sleeping units. And there are two problems with installing an alarm in these remote locations from a dwelling unit or a sleeping unit. First, the UL product standard for CO alarms, that being UL 2034, okay, very clear. These alarms are only intended to be installed in dwelling units and sleeping units. Second, and probably more importantly, is no one will hear the audible alarm signal because these remote locations are typically in an unoccupied area of the building and usually behind a locked door, such as a boiler or furnace room that's in the basement of a building. Whereas if you install a CO detector in these remote locations, it will automatically send an alarm signal to the control unit and to a remote supervising station. So let's review some of the requirements in section 915 relating to what I was just talking about. And if you look at section 915.1 and 11, it requires CO detection to be installed in newly constructed I1, I2, I4, R, and E occupancies. And the last section here at the bottom, 915.1.2, it covers buildings with a fuel burning appliance that is installed in sleeping units and dwelling units. Okay, makes sense. Now this section allows either alarms or detectors to be installed in the dwelling unit or sleeping unit that has that fuel burning appliance by using the term detection. And as you can see, there was no change made to this section. So the first section to be changed is section 91513, which covers dwelling units and sleeping units that are served by a fuel burning HVAC system. And alarms or detectors are required in each dwelling unit or sleeping unit that is served by that HVAC system. Now the exception down here, okay, states that detection is not required in each dwelling unit or sleeping unit if detection is provided in the first room or area that is served by each main duct leaving the furnace of an HVAC system, and the alarm signals are automatically transmitted to a constantly or to an approved location. Now, as you can see, the term detection was replaced with the word detector, which means only CO detectors are allowed in the first room or area that is served by each main duct leaving the furnace of the HVAC system. And the reason for that is that that first room or area more often than not will be in an area of the building that is remote from a dwelling unit or sleeping unit. The next section to be changed is section 91514, and this covers applications where the fuel burning appliance is installed in the building, but it is located inside the building that is remote from dwelling units and sleeping units, which, as I said, typically, in a remote area of the building, such as a boiler or furnace room that's in the basement of the building. Again, you can see the term detection was replaced with the word detector, which means that only CO detectors are allowed in that room containing a fuel burning appliance or the fuel burning fireplace. Looking at section 91515, this covers buildings with an attached private garage. And again, you can see down here that the word detection was replaced with the word detector, which means only CO detectors are allowed in an approved location between the opening to that private garage and dwelling units and sleeping units. And if you look at this section here, which relates to newly constructed K through 12 schools, for the 2018 edition of the IFC IBC, only CO detectors are permitted to be installed by removing the word detection and replacing it with detector. Also, a new section here, 91543, was added to clearly state that CO alarms can only be installed in dwelling units and sleeping units. It goes on to say also that they are not permitted to be installed in location where the code requires CO detectors. Okay, all of the changes we've discussed so far have been relating to new construction, and they were found in the IFC and the IBC. The next several slides cover new CO detection requirements in the International Existing Building Code, or the IEBC. And the scope of this code covers existing buildings that are undergoing additions, alterations, or change of occupancy. And as you can see, a new section 402 was added, and this covers existing buildings undergoing additions, and CO detection is now required in accordance with the fire code and the residential code. And as you can see, there are several exceptions, which were taken verbatim from the residential code. And the exception stipulates that CO detection is not required where work involves replacing roofing, siding, windows, doors, or the addition of porches and decks. And this will change, well, number one, help to protect building occupants in existing buildings, but it'll also provide consistency between the IFC, IRC, and the IEBC. Continuing with the IEBC, this section 40311 covers buildings undergoing alterations, and CO detection is now required in accordance with the fire code in assisted living facilities, hospitals, nursing home, daycare facilities, and all residential occupancies. And as you can see, it has some exceptions, and these exceptions are essentially the same as what we just reviewed on the previous slide. So if you look back, all right, the IFC IBC has required CO detection in newly constructed IR occupancy since the 2012 edition, but there were never any requirements in the International Property Maintenance Code to maintain these products and systems. So if you look at this change in the IPMC, Property Maintenance Code, it now requires alarms and detectors to be maintained in accordance with NFPA 720 and requires CO detection devices to be replaced when they become inoperable or they begin producing end-of-life signals. Okay, very quickly, I don't know if this will apply to this group, but it's important, and this change relates to the residential code, and it will enhance the safety of residents by requiring CO alarms to be interconnected when more than one is installed in a detached 1- and 2-family dwelling or a townhome, not more than 3 stories. Now, interconnection provides early notification and evacuation of occupants when a CO leak occurs, for example, in the basement where you might have your furnace, by notifying the occupants on the 1st floor and the 2nd floor. Now, the residential code has required smoke alarms to be interconnected when more than one is installed in the residential code for pretty much decades, and the ICC membership thought it was really time that the same applied for carbon monoxide detection. Okay, Kathy, it looks like we're ready for our first break. Do we have any questions?
We do, Richard, and we have 4 of them, and I'm going to start with the funniest one first, because this is, and the question starts out that totally serious here. So it's a serious question. Can a dirty litter box cause false CO alarms?
It could, okay. And I say that because it depends on the sensing technology of the CO sensor. And the one sensing technology that is used in most frequently is electrochemical sensor and sensing. And it is very sensitive to hydrogen and ammonia. Okay, so that's why they always say that if you clean your detector, don't use Windex or something like that, because it could generate a false alarm. Just clean it with a damp towel or rag. So a litter box, that could potentially generate a false alarm, and that's one that I have not been asked. So whoever asked that question, that's a first in probably 10 years. So kudos to you, and I will check that out.
Okay, thank you. Then the next one is, what is the lifespan of CO sensors used in alarms and detectors?
Right now, I think just about all manufacturers of alarms and detectors use a sensing element that is good for 10 years. Wasn't that many years ago, it was in the 5 to 6 year range. But right now, I think all manufacturers, including Honeywell, everybody's at about 10 years. And obviously, when you get that audible or visible indication from the alarm, or that alarm signal from a detector sent to the control panel, you really need to get out there and replace the detector, because once that you get that signal, end of life signal, the performance of the detector will degrade quite rapidly. I mean, it's not an emergency that you got to go out and replace it within 24 hours, but I wouldn't, you know, wait a month to do it. But good question.
Okay, 2 left. Where can I find a research study about the mounting and placement of CO detectors?
That's a good question. You know, and it is the Fire Protection Research Foundation. That's the research arm of NFPA. So if you go to the nfpa.org website, there is a section, and I think it's up at the top. It talks, you know, it's up there about research, and you can go in there and you know, find this report, which I gave the title of the report in the presentation. Good question.
Okay, and then it looks like this is still the last one. Has UL considered changing the scope to allow CO alarms to be installed outside of dwelling and sleeping units?
Yes, they have. They formed a work group, and I'm thinking it was about 6 or 7 years ago, because they started to get questions like, you know, we were talking about a few slides ago, and they said, look, should we expand the scope? And the work group came back with a recommendation to the standards technical panel that alarms should not be installed in these remote locations, and that is just what I said. You know, typically these remote locations are in an unoccupied area of the building, behind a locked door, typically in the basement of a boiler or furnace room. And who's going to hear that alarm? Most likely no one. So they didn't want to make any change to the standard.
And one more question came in. Do we have enough time, or?
Sure.
I guess 2. Is there an audio level required for CO alarms? And does it need to be different than the fire alarm audible?
Oh, great question. First off, the audible fire alarm signal is the temp 3 audible pattern, and it is a international recognized signal, and it is a building evacuation signal. The carbon monoxide required audible alarm pattern is the temp 4 audible pattern. It's a much quicker, and you know, it has the 4 beeps to it, and it has the same audibility requirements as the fire alarm. But there is one other important difference between the CO and the fire alarm, and that is that the CO audible alarm signal, temp 4, is only a notification. It is not a building evacuation signal. So, but good question.
All right. Well, thank you, and you can go back to the presentation. I think we're done for now.
Okay. So, all right, let's switch gears and look at you know, some of the changes to the 2018 edition of NFPA 101 and NFPA 1. Now, I realize that these NFPA codes are not as widely adopted in the U.S. as the I codes. However, you know, a few states do adopt these codes, okay, and these codes are frequently adopted outside of the U.S. You know, for example, Florida and Georgia, I think they use NFPA 1 or 101 as the basis for their fire prevention code, and then Massachusetts, they have adopted NFPA 1. So these are very important codes. So let's you know, take a look at these. And many of the changes to these 2018 codes are essentially the same as the changes we just reviewed for the I codes. But I mean, they're structured a little differently and they are worded a little differently. And that's because, you know, these codes are formatted a little bit different than what the I codes are. And the first change revises section 14.3441 so that only CO detectors are permitted to be installed in newly constructed K through 12 schools by deleting the reference to CO alarms. Also, down here is a new section, 14.3442, and it's requires the CO detector to automatically send the alarm signal to an approved on-site or off-site location in accordance with NFPA 720. Sort of continuing with this same thing here, looking at hotels. And, you know, Chapter 28 of NFPA 101 covers hotels. And Section 28.3474 was revised so that only CO detectors will be allowed in locations where the fuel burning appliance is installed inside the building, but it is installed in an area of the building that is remote from dwelling units and sleeping units. And but the code will continue to permit alarms to be in accordance with their UL 2034 listing, which is in dwelling units only. Again, if you look at the new section at the bottom of the page here, it requires the CO detector to automatically send an alarm signal to an approved on-site or off-site location in accordance with NFPA 720. And changing gears a little bit here, as you can see, this deals with apartment buildings, and Chapter 30 of these NFPA codes, or 101, deals with apartment buildings. And Section 30.3464 was revised, so only CO detectors will be allowed in locations where that fuel burning appliance is located inside the building but remote from dwelling units, which is, again, is probably in the basement of the building for a boiler or furnace room. And this section here at the bottom, new section 30.3465, it requires that the CO detector automatically send that alarm signal to an on-site or off-premise location in accordance with NFPA 720. So now we're going to talk about board and care facilities. And the ICC has required detection in halfway houses and assisted living facilities since the 2012 edition of the IFC and the IBC. For the 2018 NFPA codes, CO detection is now finally required in small and large residential board and care facilities. Now, NFPA defines a residential board and care facility as an occupancy used for lodging and boarding of 4 or more residents that are in need of non-nursing care facilities, okay? Now, these residents are not related by blood or marriage to the owner or the operator of the facility. And several examples are assisted living facilities, group housing for physically or mentally disabled people. So looking at small board and care facilities, this is a type that is has fewer than 16 residents, and CO detection is now required by 32.23441 when the facility contains a fuel burning appliance or when they have an attached communicating garage. Now, the next section here at the bottom of the page, it requires CO detection to be installed, number 1, outside of each sleeping area in the immediate vicinity of the sleeping room. Number 2, within sleeping rooms that contain a fuel burning appliance or a fuel burning fireplace. Number 3, on every occupiable level, including basements, but excluding attics and crawl spaces. And number 4, centrally located within occupiable spaces that are adjacent to the communicating attached garage. So still looking at board and care facilities, but we're going to look at large board and care facilities. And this is a facility that has more than 16 residents. And looking at section 32.33491, it now requires CO detection when the facility contains, yes, a fuel burning appliance or when they have an attached communicating garage. And just like small board and care facilities, this next section requires CO detection to be installed in these following 4 locations. However, and we're continuing with large board and care facilities, okay? In addition to the sleeping area requirements, CO alarms or detectors are required to be installed in the following non-sleeping locations. Number 1, on the ceiling in rooms containing a permanently installed fuel burning appliance. And second, the second requirement is for detection to be centrally located within occupiable spaces served by the first supply air register of the HVAC system. So now there's a little bit of consistency between these NFPA codes and the I codes. Okay, this is a very interesting and I think very important change, and it's intended to protect the public and workers from serious injury or possibly death from unintentional non-fire related CO exposure by mandating the installation of CO detection devices in assembly occupancies. This proposal was developed and submitted by the National Electrical Manufacturers Association, and it requires CO detection in assembly occupancies like restaurants, nightclubs, motion picture theaters, places of religious worship. And CO detectors are now required in the following 3 locations: on the ceiling of the room containing the permanently installed fuel burning appliance. Number 2, centrally located within an occupiable space served by that first supply air register from a fuel burning HVAC system. And number 3, centrally located within an occupiable space adjacent to the communicating attached garage. Now this section at the bottom of the page, okay, is pretty important. It says where CO detection is not required. Obviously, you don't want to install CO detection in garages, but you know, that's very important. Okay, Kathy, I think we got time for a couple more questions.
Okay, sorry, I was muted. We have a couple.
Did I put you to sleep?
No, no, you didn't. I had to take another call. Okay, the first one is the reference to a 10-year lifespan refer to both indoors and garages?
Basically, the check with your manufacturer, published instructions, okay? You know, I probably misspoke. To my knowledge, all of the indoor you know, products are at 10 years, but who knows, there may be somebody out there that just introduced one that can go 12 years, or maybe somebody is still at 6 years. But the same thing goes for detectors that are installed in parking garages. You really need to check with the manufacturer's published instructions.
Okay, looks like there's 2 more at this point. What is the immediate vicinity? What did you mean by that?
Yeah, that's one that I get quite a bit, and I hate that term because really it's undefined and it's very difficult to enforce. But what I always like to say is that, you know, it says in the immediate vicinity of the sleeping room or the bedroom. So what you want to do is have sufficient audible level at the pillow to wake someone up. So if you're you know, installing a CO alarm or detector that is outside the bedroom, okay, NFPA 720 requires 75 dB at that pillow with the door closed. And if you can't get 75 dB, then you're going to have to install a CO detection device or a horn inside the bedroom. But that's typically what I like to say is immediate vicinity. Make sure that you have 75 dB at the pillow.
Okay, and I think this is the last one. There are different placement requirements in the codes and NFPA 72?
And NFPA 720, yes, and I think that'll become apparent here pretty quick. But in 720 and now 72, it has some pretty expansive requirements in there. But it also says install where required by applicable codes, laws, and as we all know, the requirements in a code will override the requirements that's in an installation standard. And 72 and 720 is really an installation standard. So I would always say go with what's in NFPA 101, NFPA 1, the IFC, or the IBC.
Okay, and it looks like that's it for now. I know you have a little bit more to go.
Okay. Okay, so let's take a few minutes and look at why the NFPA Standards Council essentially said, look, we're going to do away with the CO detection standard, that being NFPA 720, and merge those requirements into the 2019 edition of NFPA 72. And I think to really understand why the Standards Council made this decision is let's just kind of take a minute and review the history and development of 720. And the first edition of NFPA 720 was published in 2003, and it was a recommended practice that covered only household applications and CO alarms. Obviously, as a recommended practice, it did not contain enforceable language, which is kind of commonplace when a new document is introduced. The first 1 or 2 cycles, get it out there, let's see what the public has to say. Now, the 2005 edition was changed from a recommended practice to an actual standard that included enforceable language, but it only contained requirements relating to households and to CO alarms. Now, the 2009 edition was a complete rewrite of the standard, okay, and it incorporated requirements for commercial occupancies, such as hotels, apartment buildings, assisted living facilities, hospitals, and yes, K through 12 schools. And the scope was expanded to include not only alarms, but detectors and detection systems. And that was because probably in the 2007, 2008 time period, you saw some jurisdictions enacting laws or ordinances requiring CO detection in apartment buildings or K through 12 schools. Now, this 2009 standard, okay, it included many extracts from NFPA 72, which, included changing the word smoke alarm to CO alarm, smoke detector to CO detector, fire alarm control unit to a CO detection control unit. And this really made it very difficult to keep up with the changes to 72 and 720, because if you stop and think about it, every new edition of 720, the NFPA staff and the technical committee had to go back to the previous edition of 72 to see if anything had changed. So the NFPA Standards Council in 2015 approved a project to do away with 720 and merge the key requirements into the 2019 edition of 72. And this change was made possible because back in 2010, the scope and the title of NFPA 72 was changed from one being totally focused on fire alarm to include other types of signaling systems, such as carbon monoxide or mass notification. So that was the reason why, this decision was made. So let's take a few minutes here and review some of these key requirements, not all, but some of them that was merged over from 720 into 72. And it will actually be, I think, a good review of, some key points and to emphasize some of the discussion that we've had already today. So the first chapter we'll look at is chapter 17 of 72. And this chapter covers all types of initiating devices that are connected to a control unit. And a new section relating to CO detectors was added, okay, that being 17.2 or 1.2, 17.12. And if you look at 17.12.1, it requires detectors to be installed in the following locations where required by laws, codes, or standards. Number one, on the ceiling in the same room as a permanently installed fuel burning appliance. Makes sense? That's a no-brainer. Number two, centrally located on every occupiable level and in every HVAC zone of a building. All right, that's pretty expansive. Number three, outside of a sleeping area within 21 feet of any door leading to a sleeping room. Number four, other locations where required by applicable laws, codes, or standards. And number five, it allows for a performance-based design in accordance with section 17.3. And that performance-based design, that is typical with smoke detectors. So, if you look at item number two, 72 and formerly 720 was requiring a building to have CO detection in every occupiable level and in every HVAC zone of the building. And that would a lot of times just require CO detectors throughout all areas of a 4-story, 5-story hotel, where that might be overkill. You may only need it in the room where there's a fuel burning appliance, and that's where the code's required. Continuing with chapter 17, 17.12.2, it requires CO detectors to be listed as complying with UL 2075, and that is the UL product standard for system connected CO detectors. And if you look at subsection 2 here, it requires the alarm thresholds for detectors to meet the sensitivity limits or the alarm thresholds that are specified in UL 2034. And 2034 is the standard for single and multiple station alarms. So even though you have separate product standards for alarms and detectors, they both have the same alarm thresholds, which is a question that I get quite a bit. Now, 17.12.3 and 17.12.4 are really intended to reduce unwanted alarm activations. Looking at 17.2.3 or 17.12.3, I got to make some changes to the presentation. It requires CO detectors to be located and mounted so that accidental operation will not be caused by jarring or vibration. 17.12.4 requires the location of the CO detector to be based on a evaluation of the potential ambient sources and flows of carbon monoxide gas, as well as moisture, temperature, dust, or electrical or mechanical influences. Okay, let's switch gears and look at chapter 18 of 72. And this chapter covers all types of notification appliances that are connected to a protected premise control unit. And section 18.431 and 18.432 require the audible alarm signal, the CO audible alarm signal, to be distinctive to CO, and it has to be different than the Temp 3 audible fire alarm evacuation signal. And it requires this audible CO alarm signal to be this Temp 4 audible alarm pattern, which I think was a question that we just got a few minutes ago. So let's kind kind of switch gears here, look at chapter 23, which in the past it covered the requirements for the installation and performance of fire alarm systems located at the protected premise. Now, the first change to chapter 23 changes the scope beyond just fire alarm systems to include all types of signaling systems. And this change paves the way to incorporate the requirements from 720 into 72. And as you can see, the text in the body and the annex is pretty clear that the scope of chapter 23 covers carbon monoxide detection. So looking at paragraph 23849 of the 2016 72, it required signals from an activated CO detector to be transmitted to a fire alarm system to be indicated as an alarm signal. But there was an exception that where required by the AHJ that the signal transmitted to the fire alarm panel could be a supervisory signal and not an alarm signal. So to comply with NFPA's manual of style, which is essentially trying to do away with exceptions and really putting it into a actual requirement, the exception was replaced with this new requirement. So here's these three sections address when and if building-wide audible and visible notification appliances is required. NFPA 720, now 72, permit but do not mandate the installation of CO horns and strobes throughout the building. Now, looking at new section 238612, it requires occupant notification of a CO detection system to be throughout the protected premise, except as permitted by 238613. So what is 238613 states? Well, it says that it permits selective mode occupant notification to be limited to the notification zone encompassing the area where the CO alarm signal was initiated, and if and only if the CO alarm signal is transmitted to a constantly attended on-site or off-site location. And 238633, it covers the boundaries of the notification zone, which is the area where the CO alarm signal originated, or other signaling zones in accordance with the building emergency response plan. So the building emergency response plan, okay, may say they want building-wide CO horns and strobes. But it also may say, okay, we just want to limit it to where the CO alarm signal originated at, and maybe going back to a few different rooms within the building. So it's really up to the evacuation plan. So let's take a minute here and look at chapter 29. All right, and this covers how to install, service, and maintain single and multiple station CO alarms and household CO detection systems. And it's really important to note that chapter 29 is not an occupancy chapter. Rather, it covers all types of locations where a CO alarm may be installed. And as you can see, a new section 29.6 relates to carbon monoxide detection. New section 29.611, it says that CO alarms and detectors are required in the following locations, which we've pretty much well covered so far in this presentation, or where required by laws, codes, or other standards. Okay, and looking at 29.612, this goes back to one of the frequently asked questions. It says that each alarm or detector shall be located on the wall, ceiling, or other location as specified in the manufacturer's published instructions. And then you know, the interconnection of alarms, not detectors, but the interconnection of alarms, and that is, you know, where you have more than one alarm within a dwelling unit or suite of rooms. So when one goes off, they all go off. Okay, Kathy, I'll turn it back over to you. And Billy?
Well, thank you, Richard. There's a couple more questions. And one, I think I'll just answer. Someone asked if this presentation is going to be available to attendees, and the answer is both. The webinar recording will be available on both the APA and the CCFS websites. I know if you need a copy of the presentation, you can, Richard, do you want them to get in touch with you, and we'll have it on the CCFS site too? Or
yeah, I mean, if somebody has a question for me, you know, here's my contact information. It's best to send me an email because I travel quite a bit on business, or if you want a copy of the PDF, I'll be more than happy to send it to you.
Okay. And looks like two more questions. Are the alarm signals from a CO detector required to be sent to a remote supervising station?
Wow. I would say that, to my knowledge, there's nothing that mandates it. But if you stop and think about it, you know, in commercial occupancies, the vast majority of times, the CO detector is connected to the fire alarm control unit. And the model codes, IFC, IBC, NFPA 1 and 101, require fire alarm systems to be monitored by a remote supervising station. So if you're connecting the CO detector to a fire alarm control unit, you might as well send that signal to the remote supervising station, because certainly you want a responsible party to be notified if there's a malfunctioning fuel burning appliance.
Okay, and there are two more, and this one might be a little bit similar. Is the alarm notification for CO the same as smoke or fire? If notifications are announced in a certain area, will the occupant know what's going off?
In terms of the audible alarm signal, you know, fire is the temp 3 audible alarm pattern. Carbon monoxide is the temp 4 audible alarm pattern. And I would say that the general public, the vast majority of them, don't know the difference between the temp 3 and the temp 4 audible alarm pattern. You know, and I think that's another good reason that if you only you know, have the CO occupant notification in the area where the CO signal was initiated, and send that alarm signal to a constantly attended on-site or off-site location, then you can have a responsible party come and check out what's going on, instead of, you know, for example, you know, a 5-story Hampton or Marriott hotel. You know, instead of dumping the whole hotel at 3 o'clock in the morning when there's a blizzard out there, you can have somebody that is on site, that is trained to take appropriate action, and the remote supervising station person will be there 24/7, 365 days a year, and they can take appropriate action and come out and really find out what's going on, and before they dump the whole building.
Okay, and it looks like we get another second question too, so two more.
Okay.
Earlier, you mentioned that CO alarms or detectors can be mounted on the walls or ceilings based on the density similarity with air, and there were no distance requirements for CO spacing. Why does NFPA 72 require ceiling-mounted detectors and within 21 feet?
That has to do with the heat generation and the flume of the fire, okay? And you will notice that there are requirements in the codes and 72 that if you're installing the CO detector in the room where the fuel burning appliance is located, it says on the ceiling. Obviously, that fuel burning appliance, it generates heat. It's going to make the gas buoyant, which will raise it to the ceiling. But, you know, if you're installing that CO detector, okay, in an area that is not where the fuel burning appliance is located, then you don't have that buoyancy that's forcing the CO gas to the ceiling. You know, in the HVAC system, as it's running, it will circulate that CO gas very quickly within a room or a space. And even if the CO or even if the HVAC system is not running, if you just have people walking around in a dwelling unit or a building, all right, that'll generate air currents and it'll stir the CO gas. And so that's why, you know, they say that you can, you know, install it on the wall or ceiling. Now, you know, if you're getting into an ice rink, all right, that could be a really large venue. You know, theoretically, okay, you only need one in there, but that could be a large area. And I would just say use common sense. You know, maybe you want to install 2 or 3 in there just to cover your rear end. Long answer, I know. I hope that answered the question.
Okay, we're coming up to our limit on our time. If your question was not answered, you will get a response from Richard here shortly. All the questions will be sent to him, and he'll reach out to the person asking the question. On behalf of APA and CCFS, I would like to thank everyone for their time today. And Richard, thank you so much for a very informative presentation. We appreciate you taking time out of your busy schedule to do this.
I thoroughly enjoy it. Anytime I can get in front of a group of people and, you know, talk about fire alarm or talk about, you know, carbon monoxide mass notification, I just truly love it. So thank you for the opportunity.
And thank you.
Thank you, everyone.
Billy. Thank you, everyone.
Thank you. Have a great afternoon. Bye-bye now.
Bye-bye.